The energy of movement is called kinetic. Why? Because of the rock's position on the edge of the cliff. It hasn't any movement so far, but it looks as if it's on the point of having quite a lot of movement any minute now. Because the force of gravity wants very much to make it fall off the cliff. That means that, in a sense, the rock has a lot of energy stored up in it. A lot of what scientists call potential energy, or the energy of position. The slightest puff of wind, and that potential energy will immediately start being transformed into kinetic energy. That's how the energy of position becomes the energy of movement.
To a spring, and then the more you push up on the spring, the more potential the block has on going down on the higher velocity. So basically, there's potential energy here. Oh, sorry about that. So basically, there's potential energy here at point A. It's potential energy, and at point B, since the block since let's label this, let's make this the surface, and let's make this the reference line where potential energy is equal to 0. So we know at this point the potential energy is 0, and then that the block would be moving at this point, and then it would only have kinetic energy of motion basically. And we know at point C it wouldn't have kinetic and potential because it's going to be moving, it's going to be accelerating at this point. So it's going to have kinetic energy and potential energy because it's at a height 2r, the diameter basically, 2 times the radius. It's going to be 2r. So it's going to be kinetic here and potential energy here, and potential energy there. So now we could write this all in an equation. We know conservation of energy. We know the sum of all the energy initial equals all the energy final, so of this block. So we know that the block starts out having potential energy, and then when it goes to from A to B, let's say that the block has potential energy, and from A to B, let's just use conservation of energy from A to B. We know conservation of energy that all the energy initial equals all the energy final, right? This is the conservation of energy equation. And we know the formula for potential energy is mgh, and we know that the block starts from rest, so we could say so let's just write that potential energy at point A plus the kinetic energy at point A must equal the potential energy at point B plus the kinetic energy at point B. So we know that the kinetic energy at point A is 0 since it starts from rest, there's no motion, and that the potential energy at point B is 0 because it's because we defined that the potential energy equals 0 at this surface. So basically we could derive a formula. We know that the formula for potential energy is mgh. The formula for kinetic energy is 1/2 mv squared, right? So we could just write an equation. Using what we know, that mgh is the potential energy at point A. mgh at point A equals, we know that the kinetic energy was 0, equals the equals the kinetic energy at point B, because the object is moving, but it's not object moving, and we define the potential energy at equals 0, because the only thing that's relevant is the change in potential energy, so we could make the reference line anywhere we want. So we just cancel out the masses, and you should get that this velocity at point B, the velocity at point B should equal basically, it should equal the square root of 2gh. Square root of 2gh is equal to the velocity at point B. Because why? I mean, this is just a math thing, but you multiply 2 on both sides, you get 2gh, and then you square root that, and you get 2gh equals the velocity at point B. So we know that the velocity at point B is 2gh. So we could erase this then. And we already know that the velocity here at C is gr. Let's erase this. So we have to write another formula for energy. The energy here will only be kinetic energy, and the energy there would be potential and kinetic energy. So we write a formula for this, saying that kinetic energy at point B, since that's the initial energy, if you're dividing into two systems, that's the kinetic energy at point B, and then at point C, it's going to be potential energy plus the kinetic energy at point C, right? At point C, or at point C. Oh. Okay. So this equals the kinetic energy at point C. So let's just write the formula for this. We know that 1/2 mv squared is the formula for kinetic energy. We don't know the mass of the clock. We don't even need to know. And we know that the velocity at point B is the square root of 2gh, since we already defined that. Square root of 2gh squared equals the potential energy at point C. I mean the potential energy at point C, which is basically 2r, 2 times the radius. So we just do mg, the height, which is 2r, plus the kinetic energy, which is 1/2 mass times the velocity at point C, which is the velocity squared at point C is just gr. So we could just write gr here. We don't even need. We could just write gr, right? Because we know that kinetic energy is the same as 1/2 mass times velocity squared. So we already know that the velocity squared is gr. So we could just plug in 1/2 mass times gr. So we cancel the masses out. And we should get that 1/2. When you just cancel all the masses out there, and then you'll get when you cancel all the masses out, you get, let's just write it there so we don't forget. Just write it here so we don't forget. 1/2 2gr, 2g times the height squared. I don't think we'll have space to write that, so just erase the whole thing and triangle. So just, and then write down right here that 1/2. This is just a formula canceling out all the masses. So G squared R is the same as 2GH, right? And that equals potential energy here. So G, since we cancel the masses out, G times the height, which is just 2R at point C, plus the kinetic energy, which is just 1/2, cancel the masses, GR. So basically you could simplify this formula to find this height, because we know that this height is the same as this height right there. When you simplify all of this, you'll eventually get that the height must equal 5R over 2. Wait, the height must equal 5R over 2. 5 times the radius over 2. So I hope that was helpful. I defined what potential energy is, kinetic energy, and I defined what normal force is. So in the next video I'll show you about momentum and stuff. Thank you very much, and see you in the next video.
The Toyota Aygo Steve had chosen for the stunt had been heavily modified to make it strong enough and hopefully safe enough should things go wrong.
Here we go, this is it. This is it. Whoa, we're going in too fast. And here we go.
And